All right, so let's go ahead and talk about solving one-step inequalities. So for the most part, the steps for solving inequalities are the same as the steps for solving equations. There is one difference, which we'll get to a little bit later on. But just like with equations, the inequality symbol is the middle of an inequality in the same way that the equal sign is the middle of an equation. But the rest, most of it, is the same. You still have to isolate the variable in order to solve the inequality. So let's go ahead and take a look at these examples here. So here, x plus 5 is greater than negative 7. In order to isolate x, I need to eliminate or undo this plus 5. How will I do that? I'm going to subtract 5 from both sides. Here, 5 minus 5, they cancel each other out. And this leaves me with x on my left side is greater than negative 7 minus 5, same sign, add them together, keep the sign, is negative 12. So you could also check your solution to an inequality by selecting a value for your variable that fits your answer statement. Here my statement is x is greater than negative 12. So if I choose a value greater than negative 12, say for example negative 4, and plug it into this inequality, I can test whether or not it would give me a true statement. So now instead of writing x, I'm going to write negative 4 plus 5. Is that greater than negative 7? So here negative 4 plus 5 is 1, and 1 is most definitely greater than negative 7. So this is a true statement. Let's take a look at our next example. Y minus 10 is less than or equal to negative 35. So in order to isolate y, I need to eliminate this negative 10. How am I going to do that? By addition. So I'm going to add a 10 to both sides. These cancel out, leave me with y on the left-hand side. My symbol this time is less than or equal to, and negative 35 plus 10, different signs subtract, and keep the sign of the greater number, or the number with the higher absolute value. That's the best way to say it. So my solution is y is less than or equal to negative 25. And again, I can test that out. If I choose a value for y less than negative 25 and plug it in, let's see if I get a true statement here. So let's pick less than negative 25, let's pick negative 30. So instead of y, I'm going to put negative 30 minus 10. Is that less than or equal to negative 35? So here, what's negative 30 minus 10? It's negative 40. And negative 40 is most definitely less than, okay, negative 35. You can't possibly have a number that's less than and equal to at the same time. That's why it's an or. All right, our next example. Let's take a look at some examples with multiplication and division. Over here, we have 5x is greater than or equal to negative 45. And just like with an equation, in order to eliminate multiplication by 5, I have to divide both sides by 5. So over here, 5x divided by 5, that cancels out, leaving me with my x on the left-hand side is greater than or equal to, and negative 45 divided by 5 is negative 9. And again, let's go ahead and choose a value. So if x is greater than negative 9, let's pick another number greater than negative 9. Let's go crazy. How about negative 8? Is negative 8 greater than negative 9? It sure is. So I'm going to say here, 5 times my chosen value for x, which is negative 8, is that greater than or equal to negative 45? So what's 5 times negative 8? It's negative 40. And is negative 40 greater than or equal to negative 45? Yes, it is. So this is my true statement there. Next example, division. So I have y divided by 3 is less than, this is supposed to be 2. Well, there it is. All right. So y divided by 3 is less than 2. And how do we undo division? By multiplication. So I'm going to multiply both sides by 3. And we end up with the solution y is less than 6. So let's test that out. And since there's division by 3 involved here, we should pick a value less than 6 that's divisible by 3. How about 3? All right, let's go ahead and try that out. So 3 divided by 3, is that less than 6? Then 2, sorry, not 6, 2 from up here. So what's 3 divided by 3? 1. And 1 is most definitely less than 2. So far that works. And I hope that makes a lot of sense to you. Let's take a look at the examples that I mentioned before, where solving an inequality is different than solving an equation. So we look here and we see the inequality negative 2n is less than negative 10. Let's go ahead and solve it the same way we've been doing the others. So in order to undo multiplication by negative 2, I'm going to divide both sides by negative 2. So I end up here with n on the left-hand side is less than, and negative 10 divided by negative 2 is positive 5. So n is less than positive 5. So let's test this solution and see if it works. How about 2? Is 2 less than 5? Yeah. So we're going to say, okay, negative 2 times our chosen value for n, 2, is that less than negative 10? So we're going to work that out. Negative 2 times 2 is negative 4. So is negative 4 less than negative 10? No, it's not. This is a false statement. Negative 4 is not less than negative 10. So the question here is, what happened? Why did this turn out false if we followed all the correct steps? Well, the key is in what happened right here with this symbol. And so there's a rule that we need to learn about solving inequalities, solving multiplication or division inequalities that involve negative numbers on the coefficient, okay? So here's the rule. The rule is when you have to undo multiplication or division by a negative number, then you have to reverse the inequality symbol. So what I should have done here, everything I did here was correct. The only difference is I should have reversed this less than and turned it into a greater than. Let's clarify here. The reason why that's happening is because since this coefficient here is a negative 2, I had to divide by a negative 2. That's what causes the switch here. It has nothing to do with this negative 10 on this side. It only has to do with the fact that this coefficient was negative. So let's go ahead and test it and see. So now let's choose a number greater than 5. Let's choose 7. So if I say here, negative 2 times 7, is that less than, because the original inequality is less than, negative 10. So negative 2 times 7 is negative 14. And we can see here that negative 14 is definitely less than negative 10. So remember, this switch happened. It had nothing to do with this negative 10. It had to do with the fact that since the original inequality statement had multiplication by negative 2, we had to undo multiplication by a negative number, which meant I had to switch the inequality sign. I had to reverse the inequality. All right, so let's go ahead and take a look at this last example. This last example says negative y over 4 is greater than or equal to 5. So one thing to remember about fractions is if a fraction is negative, you could put that negative sign next to the top number, next to the numerator. You could put it next to the denominator, or you could put it in the middle. For a situation like this, it's better if you move that negative sign next to the denominator because it's going to help you see what you need to do. So in this situation here, I have to undo division by negative 4. So in order to do that, I have to multiply both sides by negative 4. So we cancel here, leaving me with y. On the right side, 5 times negative 4 is negative 20. And here, since I had to undo division by a negative number, I have to take this inequality and reverse it from being a greater than or equal to a less than or equal to. Remember, I'm doing that because of this negative 4 here. It has nothing to do with the fact that the answer has a negative 20 in it. So my solution is y is less than or equal to negative 20. Let's go ahead and test whether or not we are right. Let's choose a value less than negative 20 that is divisible by 4. So how about negative 28? Okay, so instead of y, I'm going to put here negative 28 divided by negative 4, is that greater than or equal to 5? So let's work it out and see. What is negative 28 divided by negative 4? Well, it is positive 7. And so is positive 7 greater than or equal to 5? Yes, it is greater than 5. So this here is my true statement. So I hope this helps you to understand the basic steps for solving one-step inequalities.